Hi, in this video, we're going to be learning or continuing to learn how to factor polynomials. In a previous video, we talked about the challenge of factoring polynomials being associated with the fact that there are multiple techniques that are associated with different types of problems. So I've included a flow chart in the description below to help you to decide what technique to use and when. All right, so before you get started on factoring any polynomial, the first thing you always want to do is make sure that polynomial is in standard form. Then you want to factor out a GCF if there is one. And once you've done that, then you have to count the number of terms. All right, so in this video, we are going to be focused on three-term quadratics. So we are going to be looking at the quadratics, which this is not a quadratic, it is a quartic. So remember that a quadratic has the highest exponent of 2. Here we have our leading or highest exponent or degree is 4. Now the question is, can we turn this into a quadratic? Can we make a substitution that turns this into a quadratic that we do know how to work with? And my argument is yes. And here's how you know. If your polynomial has a degree that is twice as much as that middle term, then you know you can turn this into a quadratic. All right, let's see how. So remember that our middle term in a quadratic always has the variable with an exponent of 1. All right, so if we can replace this with a variable with an exponent of 1, so let's say x squared, let's call it some other letter. I'm going to choose p. Then our middle term then becomes negative 3p. Our last term is still 18. And our first term is p squared. All right, p squared works because that is x squared squared, which is in fact x to the 4th, which is what we want. So now looking at it with the p's, that becomes a lot easier to factor than what we were originally looking at. So now we can factor our quadratic. We're looking for two numbers that multiply to give us 18 and add to give us 3. And so our two numbers would be 6 and 3. And thinking about the signs, we want them to multiply to give us negative 18 and add to give us negative 3, which means our negative 6 has to be negative, or 6 has to be negative, and our 3 has to be positive. So let's double check to make sure. When you multiply negative 6 and 3, we get negative 18. When you add negative 6 and 3, you get negative 3. That's what we want. All right, so now we factored it, but remember our original expression did not have a p. So remember that our p is x squared. So now we can put it back. All right, so everywhere you see p, we're going to replace it with x squared, and we get x squared minus 6, x squared plus 3. Now at this point, you would want to see if this is a special pattern for two terms. Is this the difference of two squares? Or is it the sum of two cubes or the difference of two cubes? It is not, which means that this is fully factored and we are done. All right, let's do a slightly harder one with a bigger exponent. So remember the thing we said to check for. In this case, In this case, we don't have a 4, we don't have a 2, we have an 8, which seems very big, but it is just twice what this is, which is what we want. So we want that term to be a single variable. I'm going to use p again since we're used to it. So in this case, p is x to the 4th, and now we have negative 13p plus 36, and this just becomes p squared. And again, just to make sure here that this is what we want, if p squared is that first term, that means that's x to the 4th squared, which is in fact x to the 8th, which lines up with the actual first term. That's what we want. So we are good to now factor that quadratic. So now we're looking for two numbers that multiply to give us 36 and add to give us negative 13. And so our two values there are 9 and 4. But because we want them to multiply to a positive number and add to negative 13, both of these numbers are negative, and we put our p's here. And again, don't forget, we did not start with p's, so we have to put our x's back. And so when we substitute the x back in, we get x to the 4th minus 9 times x to the 4th minus 4. Now, we do have to check for that special pattern, and we do actually have those two-term patterns showing up here. This is the difference of two perfect squares, and so is this. And so we can factor this further, and it becomes x squared minus 3, that's the square root of x to the 4th and 9. And so we have x squared plus 3. So that's how that piece factors. And then we continue and factor the other expression, and we get x squared minus 2 and x squared plus 2. And so that, just so we make sure we know, that is that. This we factored that in green. All right, so now we check again to see if we have a special pattern. Is there a difference of two squares? Is there a sum of two cubes, a difference of two cubes? There is not, and that's how we know we have our final answer here. All right, so that is how substitution works when we are factoring a polynomial. We turn it to a quadratic and then factor.